All right, so let's graph this and find those items. The first thing we need to do is we need to leave the variable that has the square on the right hand side and the rest on the right hand side. So the variable that has the square is y, so we leave y squared minus 6y on the left, and then we're going to move the 4x, so it's negative, so now it's going to be positive. The 17 is positive, now it's going to be negative. Once we have that, we need to have a binomial square on the left. So to do that, we need to complete the square. To complete the square, we put y squared minus 6y, and then we take half of the 6 and square it. So half of the 6 is 3. 3 squared is 9, so plus 9. So now this is a perfect square. Equals 4x minus 17. To keep the equation equal, we need to add the same thing that we added there, so plus 9. So now this is actually a perfect square binomial, which we can put as y minus 3. Remember, 3 is half of 6 square, and this is equal to 4x minus 8. So now we need to leave the x by itself, so we can factor this one, and we have y minus 3 squared equals 4. Now the x is by itself, with no coefficient, then minus 2. And now we need to start graphing. So the first thing we notice is we actually have these numbers here. And if you notice the rest, the y squared equals 4x, all this, the rest is just your regular parabola that opens sideways, like this. This one opens like this. So it is the same. It's the same parabola. It's just translated by these two numbers. So what this means is that the negative 3 and the negative 2 now are the numbers for a new vertex. So we just change the signs, and so now the vertex is at x equals 2, y equals 3. So we got a new vertex. All right. That's the only thing that changes. So you can actually work with the regular one and find the focus. So the focus of this one would be 4p equals to 4, and so p equals to 1. So our focus would be like 1 right here, 1 0. But remember, this is translated. So what you do, so you got the focus at 1 0, and then you add this number. So I got the 2 here, add the 2, and add the 3. So now we have 3 3. So the focus is at 3 3. Yeah, just add the vertex. All right, so we got the focus. Same thing with the directrix. So the directrix would be like right over here. Normally would be, or this equation would be x equals minus 1. So x equals minus 1. So to get the true directrix of this equation, then just add this x right here. So plus 2. So x equals 1. So the directrix is x equals to 1. The focal width is always 4p. So in this case, 4p equals to 4. So the focal width equals to 4. So I already graphed this equation, and let me just double check that everything jives. So we do have the vertex at 2 3. The focus would be at 3 3 right here. So, and the directrix of course is at 1, x equals 1. So to see if the focus is indeed here, we check to see if the focal width makes sense. So if the focus is right here, we measure 1 2, and then 1, 2. So I got 4. 1, 2, 3, 4. And yeah, everything is cool. And thanks for watching.